Hello, I'm Janelle Schroet, an account manager here at Materialise, focusing on the Mimics Innovation Suite software. And over the next couple minutes, I'm going to talk with you a little bit about how Mimics can be used in your product design process to help understand and define use conditions for your medical devices. So a little bit about Materialise. Materialise is a company that focuses on additive manufacturing and rapid prototyping products, but also the software that helps support that. Today we're going to really focus on the biomedical engineering softwares. So our biomedical engineering softwares that will help you define use conditions is our Mimics Innovation Suite, and it's comprised of our Mimics software, which is image processing, 3matic, which allows you to do design on anatomy, and services. And I just wanted to note that our software is ISO certified, has its CE mark, and FDA 510K market clearance, which is also a great thing to note when quality and validation are very important in your process. So what is Mimics? Mimics is a software that allows you to take CT, MRI, really any type of medical image data, bring it into the software, and from there you can segment different models. Whatever you can see in those images, you can segment, create a 3D model, and bring that to downstream engineering applications. So what we're doing is really engineering on anatomy. Mimics is one of the first of its kind to allow you to take image data and from there create 3D models that are really meant for engineering processes. You can do the segmentation, advanced measurements, and really bring all of the information that you create in Mimics to other exports such as FEA, CFD, a CAD package, a statistical analysis package, or even straight to manufacturing with rapid prototyping and computer-aided manufacturing. And all of these exports are typical packages that are used in defining use conditions or better understanding how a device is going to function. So there's a number of applications I'd like to review with you today that Mimics can be used for in helping define use conditions. The first being segmentation. This is the process of going from two-dimensional image data to 3D. And really, all of the tools we have in Mimics help you get to that 3D model very quickly yet accurately. In the segmentation process, there's a lot of ways to visualize your anatomy that can be great in discussing what the anatomy looks like, what the different pathologies are with your design team. After visualizing, you can even take it further into analysis, and this might be something as basic as distance, angle, and volume measurements, or much more advanced to statistical analysis. Like I mentioned before, you can export to MATLAB. Or if you're working with vascular systems, you can actually calculate very quickly in Mimics a centerline branch off of that vascular system. And right away, Mimics will give you information such as best fit diameter, radius of curvature, tortuosity, cross-sectional area, and all of these measurements can help you define the use conditions for your medical device, whether it be to improve old devices or maybe create a database or a library for defining new devices and what the patient population looks like. It's all possible. We can even do much more advanced analyses such as a part comparison, maybe looking at pre-op and post-op data to look at how the anatomy has changed through the surgery, or possibly looking at thicknesses. The image in the middle shows a trabecular bone structure, and we're looking at for the thinnest areas of that structure. Or even looking at the curvature. Where's the highest curvature on your anatomical model? After doing an analysis within the software, sometimes it's also nice to bring that analysis into the physical world. Here we can print models that you've created in Mimics and bring them into the physical world for communication with other team members or clinicians, or even into the testing world and create benchtop test models, maybe for cyclic testing or loading conditions or insertion testing. Medical models have really advanced over the last few years, and the number of materials possible for printing go anywhere from transparent to highly durable, even to flexible models. Another very common place to use Mimics is with FEA and CFD. Now it's possible to take patient-specific anatomy models that you create, marry them with your medical device, and run a simulation to really understand how it's going to perform. For example, here's a case where we were able to take a patient-specific data set and really look at a CFD or a flow analysis through an aneurysm. We were able to look at things like wall stress, flow patterns, and particle velocity. Something very popular in Mimics is also the ability to do virtual surgery simulations. Here we can perform different cuts, bring CAD geometries of our implants right into the Mimics software, position them, look at them on the medical image data, and really understand where the best place to position an implant is, or really how it's going to function. Sometimes bringing your CAD geometry into Mimics is nice for doing that virtual surgery, but sometimes people would also like to reverse engineer your anatomy and bring that anatomy model straight into your traditional CAD package, such as ProEngineer or SolidWorks. And this is also possible. We have some nice tools for going and creating very highly accurate anatomical iGES parts that come into your CAD package as a solid model. And this can be as simple as just one bone or as a full body CAD model, as you see here on your screen. We also have the ability to do some follow-up and comparison of models. So for example, with cardiac data, maybe you want to compare a systolic and diastolic phases and really look at how much is the anatomy changing, where are the biggest deformations, and take real-time measurements in specific locations for helping to define what kind of movement is your device seeing over the cardiac cycle. Patient-specific data can go as far as linking to musculoskeletal modeling packages. And what you can do now is not only look at how the bones are interacting, but really apply that musculoskeletal modeling and really look from a patient-specific level, how are those bones moving together and interacting. So again, there's a number of different places that Mimics is used in helping engineers define use conditions in all sorts of different markets. Orthopedic, craniomaxillofacial, and cardiovascular are three of the main ones, but there's a number of other research areas that Mimics is used. Really, the sky is the limit. All you need is two-dimensional cross-sectional images. You bring them into Mimics, you can create those models and link them to any engineering application. I'd like to thank you for your attention today, and if you have any questions on the Mimics software or how it can be used in your process, please feel free to give me a call. Here is my contact information. Or there's a couple other videos on this webpage that you can check out that will show you how Mimics works in a real-time setting. Thanks so much. Have a great day.